Or anyone outside? No? You can bring everyone else. We'll do this proper because it's nearly time. No? Cool? Okay, now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, we have everyone. Okay, so I hope you enjoyed that. My hope was that you'll get, if you don't get anything out of it in terms of theory or algorithms or methodology, at least you get to make some friends. So I hope that happened, or make some enemies, which I can do. Fight with it. Okay, can I ask the 3 team leaders to just quickly summarize the points? So within 30 seconds, tell us what are the big ideas that you came up with. So we can start. Big ideas. Just tell everyone one thing.
Big ideas is we have to we have incident information and we have to do incident map and with incident action of human and of agent, and so we have to deal with uncertainty. And yeah.
Dealing with uncertainty. So dealing with uncertainty was a big problem, and I agree with that. It's,
but it also worked for I mean the hardware. Depending on if there is a relation, electronic code could not work, for example, but there is a lot of things. And maybe some things that is new for that come after, it's also changing team. If the crisis is for a long time, you have to think about what kind of information they will know, and also know where places that will already be, I don't know, where people go the job here. Also.
Good, thank you for that.
The main idea is hierarchy structure. So there are 2 kinds of roles. First is if you're at the bottom of the hierarchy and you're the reporter, you can either like describe what's the situation of the site, or you can be a volunteer, like, oh, I have this kind of expertise and I want to help. And on top of the hierarchy would be like the human expert that try to give this rescue plan, and this rescue plan will be announced to the each of the device you're holding, and so it will guide you to what you're going to do and whether this task is finished or not. So basically, at the bottom of the hierarchy would be a decentralized system, and on top would be a centralized that is trying to organize the global situation. So,
yeah, that's last one.
Okay. So we have been discussing that all the information must be aggregated in an easily accessible platform that might be a web page. Okay, and this could aggregate also additional information from bigger websites like Foursquare, Facebook, Twitter, and maybe a specialized application for these kinds of situations. Initially, the classification of tasks will be done by the main role of each participant. If he is an employee of the state, okay, he would be the first one to go and fetch this information that we need. Also, the information must be augmented with with conceptual knowledge. Okay, where is the exact location, the time, the risk, and a ranking of the risk. Okay. So there must also be an incentivization mechanism that will rank contributors according to the impact of their contributions. Namely, if your contribution helps to save many lives, you will be the first one to appear on the news or in our platform. Okay. Also, there must be some initial filtering algorithms, just to return some outliers. Maybe some natural language processing, like topic models. And of course, all this information will be visualized on a map, divided in the tiles. Okay, so it will be easy for everybody to see where he is needed and where he's not.
Okay, thank you.
Did I forget something?
No, I think that's plenty. I mean, you've mentioned lots of interesting ideas, and what comes across is that you're obviously thinking about the right things here, and you're raising a number of issues that need to be dealt with a range of techniques. It's not one technique that deals with this, and you're going to do a PhD on one single technique, probably for 3 years, 5 years, depends on where you're doing it. What you just need to realize is where it fits in the big picture, where this might be used, and always try to motivate what you do with applications such as this. So understand what are the implications of what you're doing, understand what sort of considerations you need to make in building your algorithm, building your systems, or coming up with machine learning algorithms. So, elements you talked about in terms of classification, in terms of filtering, or that has to do with machine learning, so you might want to focus on machine learning techniques. If you're talking about optimization of, allocation of roles to tasks, people to tasks, then it's an optimization problem. It's a multi-agent resource allocation problem. It's highly combinatorial, and you might want to use to develop some quality formation algorithm for this, for this particular setting. If you're talking about decision and uncertainty, then it's all to do with LDPs and sort of approximations of these techniques. I was going to go through one potential solution which we've developed, which is a topic called Kid. It's a mixed reality game. It presents to users this scenario of a disaster response where people have to react to time-critical tasks. They are given apps to show them where the tasks will be and radiation levels in the environment, and they need to avoid the radiation levels because there's a radioactive cloud, and they need to avoid the cloud, they need to run around, go to certain locations, pick up certain tasks, go back to base. Satellite has just crashed, they're given roles, and they go and pick up those tasks, and they're given this app, tells them the health status. You can see the health status, they're given different roles, they can do different targets to go and pick up. And they're advised by a human commander, so at the headquarters. The HQ oversees the responders and the targets through a map. And then there's all sorts of bits of interface. This is the problem, you've understood the problem now, and they need to be allocated over time. I think you discussed that a bit. So these are tasks on the left and the roles on the right, so you have different roles for different tasks, and they need to be allocated over time. And the sort of planner agent we designed, which is a centralized planner, as you said in your solution, you had someone sitting at the top guiding the human responders to the right tasks. For this, we designed a planner agent that would instruct the humans, and the humans would react and say, yes, I accept the instruction or not. This is how we maintain the feeling of control in the system. They would also have to interact with the headquarters, the human headquarters, on the left there, which would supervise and advise them as to what should be done. Now we're also changing this setup a bit to let the planner agent advise the human commander instead. We're playing a bit with these sort of interactions to see what works best. And this is the sort of control loop we have in terms of interactions. The agent sends computes a plan, the humans receive a plan, the humans can accept the plan or can reject the plan, and you can keep going through that loop to get to the right plan. That's how we take into account human decision making in the system. We've done field trials of this system, with and without the planner agent, and we identified a number of issues. And basically what we end up with is this sort of general guidelines for how you should design such systems. So your agent should be able to provide plans to your human responders and offer multiple options to choose from. So the agent obviously can capture environmental features that are best at humans. It can measure, can account for radiation level changes in the environment, maybe fire spreading to certain parts of the environment, can predict such things and can do this better than the human commander. And therefore can also offer multiple options to the users to say, okay, you could go there or you could go there, and this will have this or that impact on the overall team's performance. You also need to make the interaction very simple. And in our case, we just had accept this task. This is a task for you. Do you accept or not? It was simple, accept or not. So if you reject another plan's computer for a reason, so it's very simple to understand what's going to happen. And in this case, the control shifted dynamically, so people could take control of what they were doing. Could say, okay, I'm not going to listen to the agents and just go ahead and do whatever I do. The system was open to that kind of interruption. You could constrain and say, no, you're not allowed to do anything else that's not allocated to you, but in our case, we allowed them to do that. And therefore, autonomy shifted in the system. Okay, just to summarize, what you've learned today, you've learned about human-agent collectives. I think you got, I hope, a reasonable overview of what this is all about, the different research themes within the area of human-agent collectives. We've delved a bit deeper into two areas. One is crowdsourcing. So I've given you some background on crowdsourcing, some notions of the key issues of that arise in this area, and understanding of the tools that you have at your disposition to use to crowdsource your problems. In terms of human-agent interaction, we studied this design, prototype, evaluation loop. This is sort of a methodology to design systems, to build systems, and what you need to think of is using this sort of framework to build human-agent collectives, to build systems for humans and agents. And then the activity was meant for you to try and build your own human-agent collective for a particular application. I hope we've achieved that, and I hope you've got an understanding of what are the challenges there. I didn't come up with these slides on my own. Used help from a number of people, so Nick Jennings, Long Trantan, and Enrico Costanza. So Enrico is an expert in HCI, and I work with him a lot. And Nick has been around for a long time in this field, and he's sort of started this whole field of human-agent collectives, which I think is going to have a big impact. If you need extra material, I mean, this set of slides is based on a number of papers and books, and I really recommend you the top one. So the paper written by Nick Jennings and a number of colleagues, including myself, in Communications of the ACM, which outlines the whole vision of human-agent collectives. There are a number of chapters from the Multi-Agent Systems book by Gerhard Weiss. I would really recommend the ones on DCOPS, MDPs, mechanism design, and college information. Really good chapters, really sort of state-of-the-art work described in there. There's an optimization tutorial I wrote in the Computer Journal about 2 years ago, which is also sort of talks about the techniques we used, we talked about today. Key one that you will probably not be given to read as multi-agent systems researchers is the Interaction Design book by Yvonne Rogers and others, and the Searchman book by on Plant-Instituted Action. So these are books coming from the HCI community that I'd really recommend you read, just because it will give you a sort of a different perspective on what you're doing and really understand the impact of the systems you build on human systems. There are a number of videos on the ORCID website, the project I'm working with right now, describing how human-agent collectives arise in a number of systems, a number of applications, and a number of papers I could send you links to if you want to read about the specific techniques used in these human-agent collectives. That's all for today. Thank you very much for attending the whole session. I know it's been 3.5 hours, 3.5 hours, so enjoy the rest of the evening and see you around. See you tomorrow at the other session. Thank you.